Hello everyone, we are Team Cabiyo from Bose University of Science and Technology YMCA Faridabad. Our team members are myself Khushwant along with Deepak, Karan, Kuldeep, Ajay and Chetna. Today we are presenting our prototype for the Smart India Hackathon problem titled as AI and IoT powered intelligent system for real-time elephant movement detection and prevention of human-elephant conflict, in short known as HEC in Chhattisgarh state. So now our problem statement context is that human-elephant conflict is one of the major challenges in states like Chhattisgarh, where elephants frequently move near villages, farmlands and roads. This often leads to crop damage, human casualties and also elephant deaths. The existing methods of protection like trenches, watchtowers or manual patrolling not enough and are sometimes dangerous. That is why an intelligent technology-driven system is urgently needed to provide early warning so that both humans and elephants can stay safe. So our prototype introduction is this. In this video, we will first show you our working prototype built using Arduino, sensors and the LCD display and some alerts like buzzers and the LED. This prototype is a scaled down version that demonstrates the core idea of detecting elephant movement through multiple sensors like ultrasonic, IR, vibration, microphone module and others. After that, we will show you the real application of our project, using captured forest clips, graphics and animations to explain how our system will be deployed in Chhattisgarh forest, how it will monitor elephant movements in real time and how alerts will be sent to nearby villages and other forest officials. For this prototype stage, we have built a temporary working model on Breadboard using normal sensors and Arduino boards. What is the prototype of the solution? So I am going to explain temporary prototype that I have made using breadboard and the jumper wires and normal sensors that we see in day-to-day life. Let me explain how our system works. So here you can see there are two Arduino Uno boards. This one is the master Arduino Uno boards and this is the slave Arduino Uno board. We are using two Arduino Uno board. One acts as a master, this one is acting as a master, which controls the LCD and the display keyboard. And the other acts as a slave, which is here and reads the sensor values. There are so many sensors that I am using in this prototype. This is the ultrasonic sensor and this is the touch sensor. This is IR sensor. This is a smoke detector sensor. This is a temperature sensor. This is a microphone sensor. And there is a MPU 6050 accelerometer or the gyroscope sensor. So we are using so many sensors to detect that there is an elephant or not. So we need to finally prevent the conflict between elephant and the humans. The communication between them happens through I2C protocol. The communication between the Arduino Uno, this one, and Arduino Uno, this one. This is the master, again I'm repeating, and this is the slave one. So these are communicating through I2C protocol. On the sensor side means this is the slave Arduino Uno. This measures reads the values of all the sensors that are present over here. So first I am introducing you to the ultrasonic sensor. Ultrasonic sensor measures the distance of objects like elephant. If the elephant is in front of ultrasonic sensor, it will detect and it will give the value that there is some object in front of it. Finally, we have not come to the conclusion that there is only elephant. There may be another object also, but that is an advanced feature which we will be adding in further prototype that we are improving day to day. And the next we have the IR and the touch sensor. This one is the IR sensor and this one is the touch sensor. So what is the working of the IR and touch sensor? IR and touch sensor detects the motion and the presence of the detection. Suppose there is an object in nearby the IR sensor, it will detect and it will give some value to the Arduino slave board and says that there is some object in front of it. And the touch sensor, we can, if some objects, if elephant touches something, so we will be introducing this touch sensor in the prototype also. Here we have made the temporary one, so we are not using the advanced sensors like acoustic sensor, vibrational sensor. In future days, we will be adding some more sensors like acoustic sensor. Acoustic sensor means thermal sensors, where elephant detection will be more feasible. we can detect elephant more easily. So next we have the microphone sensor. You can see this is a microphone, and this is a microphone module that I am using here. So microphone module sensor, what it does, it detects the loud sound such as elephant trumpeting. Means suppose the elephant is making some noise, it will detect, and after some threshold value it will give the reading to the Arduino slab board, and which Arduino slab board will give the I2 through I2C protocol. It will give the data to the LCD screen and the buzzer also, and the LED will blink. Next we have smoke sensor and the temperature sensor. Smoke sensor is this and the temperature sensor is this. What is the working and function of smoke and temperature sensor here? It detects the hazards, monitor environmental hazards. Suppose there is a fire, and suppose there is a temperature, sudden increase in the temperature. So these sensors will work and will give information to this dashboard which is present here. So it will detect, it will give information to the authorities, and the authorities will take action accordingly. So next we have MPU 6050. MPU 6050 is very small, which is kept here. You can see it, which is kept here. MPU 6050, it is a gyroscope sensor. Means it detects the vibrations, and it also detects the acceleration. Suppose we are making it in motion, so it will give the acceleration value, what is the acceleration, and it will give the somewhat location also. So here, what is the working of MPU 6050 in this prototype? MPU 6050 sensor, it detects the vibrations or the movement caused by large animals. When any of these cross a threshold, when any of these sensors, whatever I have discussed, all the sensors, when any of the sensors crosses a threshold value, our LED turns on and buzzer alerts immediately. I will be explaining it and showing every alert through the sensors in ahead of the video. So when any of these crosses a threshold, or LED turns on and buzzer alerts immediately. At the same time, the readings are sent to the master. At the same time, readings are sent to the master Arduino Uno and displayed on 16:4 LCD screen. Here it is the live demonstration that I'm going to give you all. Now let me show you a quick demonstration. As I bring my hand closer to the ultrasonic sensor, the distance decreases, and you can see the buzzer and the LED alert. And you can see the buzzer and the LED alert. I have brought my hand in front of the ultrasonic sensor, and you can see the buzzer is buzzing. Here this is the buzzer and this is the LED blink alert. If I trigger the IR sensor, I am removing my hand. You can see the buzzer have stopped and the LED alert have also stopped. If I trigger the IR sensor by blocking it, it immediately detects the motion. Now I am going to demonstrate it. I am bringing some object in front of the IR sensor. I am bringing it in front of the IR sensor. You can see the buzzer starts buzzing and the LED is also blinking. It is giving, both are giving the alert that there is an elephant or some object in front of this. So these sensors are working perfectly. You can see it. This is the live demonstration that I am giving. I have made this temporary project, a temporary prototype. I will be improving it in future. So this is just, as this is just a temporary, when I will improve it, I will also update in my video. So as I have removed the object, since the buzzer and the LED stopped giving the alert. Next we have the mic sensor, which reacts to the loud sound. If I will clap my hand in front of that mic, then you will see the alert is generated. Here I am making my sound with my finger, so you can see that there is an alert using the alert will be using the buzzer and the LED, which you can see here. So you can see the alert, the buzzer and the LED are blinking. Again I am trying. Now you have seen that the microphone sensor is also working perfectly. So if the elephant trumpets, then you can see the alert using the buzzer and the LED which is present over here, and so the mic sensor reacts to the loud sounds. Clap your hands either or make some other sound, you can see the alert is generated using the buzzer and the LED. Similarly, the smoke sensor reacts to the smoke, and the temperature sensor increases when exposed to heat. So these two sensors will work when there is a environmental hazard, there is fire or there is any other hazard which is taking place inside the forest, then these two sensor will come in working. So these two sensor will also give the alert using this LED and the buzzer. So I'm going to test it. I'm going to give the live demonstration of these two sensor as well. This is the smoke sensor and this is the temperature sensor which we are using here. So I'm going to give some small fire using my matchstick. You can see that I have burned the matchstick. Let me again use another matchstick to explain it in my live demonstration video, so you can see. Yeah, it's working perfectly working. You can see that it's burning. You can see that it's the smoke sensor have detected my fire, and with that also that thermo sensor, the temperature sensor is also have detected. Let me again burn one another matchstick and show you. So this is, I am again making it. Yeah, it's working perfectly working. I am giving the some exposing heat to this also. Oh great, it's working fine. So here we are ending the sensor section. So all these sensor values are clearly displayed on the LCD in real time, and this shows how our system continuously monitors and provides instant local alerts. So now I am going to explain what we will do the improvements in future for finals. So when our real prototype, permanent prototype stage will be ready, so we will add some more features, some advanced feature in this. This is simple, this is normal, which we have made it temporarily so that we can assure you all that we will be able to make a final prototype with advanced feature also. So this is just our prototype stage. This is just our normal prototype stage using basic breadboard and the jumper wires and some sensors, normal sensors like touch sensor, ultrasonic sensor, smoke sensor, thermal sensor, and this is a IR sensor like this. So in the Smart India Hackathon final round, we plan to make it way better and advanced with. With your blessings, we will make it much more improved version of this whole prototype. Stronger sensors like thermal imaging cameras and the long range motion sensors and the detectors. And we will also make AI integration to classify whether the detected movement is an elephant or something else, reducing false alarms. Suppose there is another animal in front of our system, in front of our prototype, that may also be detected as an elephant, but we will classify in further improvements when we will integrate artificial intelligence and machine learning into it. We will be able to detect different animals with different sounds, like animals with a elephant make different sound, so we will be able to make it. We will also be using image encryption, we will also be using the drone. So here we have just made it simple so that I can assure you all that we will be able to make advanced feature. Also we will be able to make final prototype of this problem statement. Next, what we will integrate into it, that solar powered standalone units that can be deployed in forest and broader areas. And we will also integrate IoT connectivity for sending alerts via SMS or a mobile app to villagers and the forest officials. We will also integrate a cloud-based dashboard to record and analyze elephant movement data over time. This will make our system highly practical, scalable, and impactful in real-world deployment. To conclude, Our prototype demonstrates the core idea of elephant movement detection and the human elephant conflict prevention system. In the finals, we will enhance it with advanced features and professional hardware designed for real life deployable solution. Thank you for watching our demonstration video. We are Team Cabiyo working towards saving lives of both humans and elephants with technology. Thank you everyone. And if you have any question, you can comment below in the comment box. And make sure to like our video and share it with others so that our prototype can be shared with so many people so they can understand, and if they want they can make their own prototype also. Have you ever wondered what happens when elephants wander out of the forest and into the villages? In Chhattisgarh, this is not a rare event, it's a daily challenge. Elephants searching for food end up in a farmland, destroying crops, damaging homes, and sometimes tragically putting life at risk. Traditional methods like fences and firecrackers just are not cutting it anymore. So, what if we could use technology to tackle this age old conflict? Imagine a system that's always watching, always listening, network of smart sensors using AI and IoT right at the forest's edge. Here how it works. A thermal cameras, vibrational sensors, and a microphone pick up the slightest hint of the elephant movement. Drones can join the patrolling scanning from above. All this data feeds into tiny computer powered by the sun, running powerful AI models right on the spot. The system does not just detect movement, it knows difference between elephant, a cow, or a person. Thanks to machine learning trained on thousands of images and the sounds, when the elephant is detected, instant action villages get alert on their phones. Sirens and loudspeakers go off, giving people precious time to get back to the safety. The system can also trigger non-harmful deterrents, flashing lights, buzzing drones, or whip of chili smoke to gently steer back elephant to safety without hurting them. But it's not just about reacting. The real magic is in prediction. By analyzing patterns over time, the system learns where the elephants are likely to go next. Forest officers get live dashboards showing hotspots, migration routes, and potential conflict zones so they can act before trouble starts. This is not just a tech showcase, it's lifeline for rural communities. Fewer crops lost, fewer homes damaged, and most importantly, fewer life at risk. It's a win for the elephant too, helping protect their ancient path, keep them out of the harm's way, and here is the best part: solar powered, low cost, and built for lasting, toughest rural environment. And it is scalable also, not just in Chhattisgarh, but anywhere human wildlife conflict is a problem by combining AI and IoT and creative thinking. I believe we can just create a future where people and elephant don't just survive together, they thrive. Thank you.